Hi everyone, Sharan here. Welcome to my channel. Today is the last day of statistics and the topic that we are going to cover today is about chi-square test. So there are two types of chi-square test. One is the goodness of fit, the other one is the test for independence. So we will go through these two types in detail with an example. So the first one is goodness of fit, so which is commonly used to check if the sample data matches with that of the actual population. So maybe in order to explain the goodness of fit with an example, so maybe if we take this particular one, like if we take spinning a particular coin and then seeing the probability of heads and tails. So let's say here we have a coin, and then we are spinning this coin for like 100 times, and we get heads for 75 times and we get tails for 25 times. So we need to see if the coin that we are using is a fair coin or not. Otherwise, in other terms, what it means is that whatever the distribution that we are getting right now, is it in line with the actual population. So what we do is we have the observed value here, so in this case, and then we have an expected value. So expected value is based on the actual probability. So in case of heads or tails, like tossing a particular coin, the expected value would be like 1/2, which is like a 50% probability. So actually, like what we have to get is we are supposed to get 50 times heads and 50 times tails, like as per the normal probability. So now the null hypothesis here is as usual, the coin is fair, which means that there is no difference between the observed as well as the expected distribution. Whereas the alternate hypothesis is they are very different, like the behaviors or characteristics are very different from each other. So what we do is, in order to do the chi-square test, we need as usual we need alpha value, which is the level of significance, which usually would be chosen to be 0.05. So here let us assume that the alpha value is 0.05. So now we are going to calculate the chi-square. We are going to do the chi-square test. So what we do is we do the summation of the observed value minus the expected value, the square, by the expected value. So as you see here, the observed value is 75 minus 50 divided by 50, where the numerator is squared, and then we add the other values too. So here we have two combinations, so we had those two different values too. So in this example, if you see the values, that the chi-square value that we are getting is 25. So now we know the level of significance is 0.05. So now in order to use the chi-square table, so along with the alpha value, we need to know about the degrees of freedom. So in this case, the degrees of freedom is 1. Is 1 because there is like two possible outcome, like head or tail. So like 2 minus 1 is 1. So based on degrees of freedom 1 as well as based on the level of significance 0.05. So if we look into the chi-square table, the value that we would get is approximately 3.8. So the value that we have got based on the calculation here is 25. So 25 is much greater than 3.8. So in this case, what happens is we reject the null hypothesis, which means that there is no difference between the observed as well as the expected distribution. So here in this case, what we are saying is we are rejecting that the coin is fair. So we are saying that the coin that has been used for the observation is an unfair coin, and hence we reject the null hypothesis. So this is about the first type, which is the goodness of fit. So here what we do is we have the sample data, and then we see if this data matches with that of the population or the standard values. So that's about the goodness of fit. So second example, the second type of chi-square test is test for independence. So in this case, so this is commonly used in predictive models as well. So let's say we have different variables in our model. In order to check if the variables that we are analyzing are dependent on each other or not. So that's the second example, which is the test for independence. So in this case, the second example, what we have is we have gender as well as we have the platform that is being preferred or that is being used by the people. So there are two platforms, mobile and website. So let's assume for time being that like the users can choose only one of these platforms. So it's either mobile or website. Website like the desktop can be chosen by the users, and then we want to see if there is any relationship between the gender as well as the platform. So here in this case, what we have is we have the observed value as usual. So based on the sample data that we have, we generate this kind of contingency table. So then what we do is we have to get the expected values. So how do we get the expected values? So it's easy to get the expected values. It is based on the observed values here. So if you see for male as well as for mobile, what we do is we see like total number of males into total number of mobile users divided by the total population. So 40 into 50 by 100. So similarly here in this case it would be 60 into 50 divided by 100. So that's how the expected value, values are being calculated. And now here in this case, the null hypothesis is the two variables that we are comparing are independent of each other. Like one value has no relationship with the other value. So of course the alternate hypothesis then means that there is some kind of an relationship between them. So the steps involved in doing the twice test here is like, of course, first we define the hypothesis, like what is the null hypothesis, what is the alternate hypothesis, and second one is we need to pick up an level of significance, which is nothing but the alpha value. So usually the alpha value that would be 0.05. So here in this case, let's assume that the alpha value is 0.05 and we have to find the critical value. So critical value is found from the chi-square table based on the alpha value that we have chosen as well as based on the degrees of freedom. So here in this case, the alpha value is 0.05 and the degrees of freedom is nothing but the row minus 1 into column minus 1. So here we have two rows and two columns, so which would be like 2 minus 1 into 2 minus 1 as you see here, which is like 1. So here, similar to the previous example, the degree of freedom is 1 and the alpha value is 0.05, which is same as the previous example that we saw. So the chi-square value here is 3.8. So now we need to do the statistic test. So what we do is the formula here is the observed value minus the expected value divided by the expected value. So this needs to be done for all the combination. So this is how the math would look like. So here if you see the observed value minus expected value, square of it divided by the expected value. Similarly, like for all those four combinations, we need to do this, and then the final value, if you see, is 16.66, so which is much greater than the critical value, which is 3.8. So here in this case, then it means that we have to reject the null hypothesis. So we are rejecting that there is no relationship between the two variables that we are analyzing. So which means the gender as well as the platform that is being commonly used as some kind of fan relationship between them. So that's about the test for independence. So this is commonly used in while model building to see in case of categorical variables to see if there is a relationship between them or not. So that's about it for today. So what we have covered is we have covered chi-square test, the types of chi-square test, which is the goodness of fit, where we saw a sample data and then we check if the sample data matches with that of the actual population or not. And the test for independence, where in this case we have variables, like when we have categorical variables, we check if they are related to each other or not. So if in case we have values which is of a continuous number, we can do other methods to find if they are related to each other or not. Like, but when there is categorical variables, like chi-square test is a good one to use to see if they have any relationship. And that's it for today. I hope you have learned something new today. And if you have learned something new, please give a thumbs up and subscribe to my channel if you haven't so far. And if you think this might be helpful for any of your friends, please share it with them as well. And Yeah, so that's it about statistics. So we have covered all the important topics in statistics. So statistics is a huge field. It's a vast field. Like many people do PhDs on a niche area. Like there are so many areas. So what we have done is we have covered like very important topics that are commonly used in a data science project. So you need to, like, I would provide some reference links where you can read more about the topic that we have covered today, as well as like you maybe as you come across new topics you can spend some time and learn about it. So the basics concepts that we have covered so far should help you in maybe in learning something new quite easily. So this should be good enough for you to get started or get started with data science, and this should equip yourself to be in a good position to learn something that comes up in the future as well. Yeah, so that's about it. Like in the next session we will be going through the SQL, like how like very important concepts in SQL and how to implement that. And bye for now. See you in the next sessions. Yeah.